Hi students, I'm Mr. Guan from Pusat Tingkatan 6 SMJK Chung, Ling, Butterworth. In this episode, I would like to introduce to you the topic of statics in lower 6 physics. In this topic, you need to achieve the following objective. First, define center of gravity and state condition for center of mass is the center of gravity. Second, state the condition for equilibrium of a particle. Third, define torque and state condition for equilibrium of a rigid body. Look at the objects around us. Some of them are small, while some are big. Some of them are not moving, while some are moving. Some objects are very small or particle-like objects. Some objects are uniform rigid body and some are non-uniform rigid body. All objects have weight, and the weight of objects can be obtained by using the equation W equal to mg. For a particle of mass 2 kg, the weight of the particle is 19.6 Newton, while for a steel bar of mass 3 kg, the weight of the steel bar is 29.4 Newton. Every object, whether it is particle-like object, uniform rigid body, or non-uniform rigid body, has a point known as the center of gravity. Center of gravity is a point where gravitational force acts on object. Center of mass is a point where all masses are assumed to be concentrated. Center of gravity and center of mass is not necessarily the same point. Center of gravity and center of mass are the same point only when the object is very small or it is a uniform rigid body. What is equilibrium? Equilibrium is a situation where resultant force acts on the system is equal to 0. There are two types of equilibrium: static equilibrium and dynamic equilibrium. Let's look at this car that is said to be in static equilibrium. There are two forces of 30 Newton act on the stationary car. The resultant force act on the car is equal to 0 and the car remains stationary. This type of equilibrium is called static equilibrium. Look at another car that is said to be in dynamic equilibrium. There are two forces of 30 Newton act on the car which is moving with uniform velocity. The resultant force act on the car is equals to 0 and the car remains to move with uniform velocity. These types of equilibrium is called dynamic equilibrium. Static equilibrium of a particle is a situation where resultant force acts on the particle at any direction is equal to 0. For a particle acted by three forces, which is in static equilibrium. If a force diagram is drawn, there are few options of diagram of forces obtained. All the diagram of forces drawn have a common condition. Diagram of forces drawn is a closed triangle that will come back to the initial position. For a particle acted by four forces, which is in static equilibrium, if a force diagram is drawn, there are few options of diagram of forces obtained depends on which of the forces you start first. Look at all the diagram of forces drawn. Once again, it forms a closed quadrilateral or a closed polygon that will return to its initial position. So, we can conclude that a particle in static equilibrium is a particle where the resultant force acts at any direction is equal to 0. If diagram of forces is drawn, the diagram of forces will form a closed polygon which will return to its initial position. Next, Let's look at an example of solving problem of static equilibrium of a particle. Problem of static equilibrium of a particle can be solved by either using triangle of forces if it forms a triangle, or using the method of resolving of forces. Triangle of forces method states that if three coplanar forces act on a particle are in equilibrium, the three forces can be represented both in magnitude and direction by the sides of the triangle taken in order. First, you can solve the problem by using the methods of triangles of forces. A triangle of forces is drawn, and the triangle is solved by using ratio of trigonometry. Beta is equal to 180 degrees minus 90 degrees minus 37 degrees is equal to 53 degrees. Alpha is equal to 180 degrees minus 53 degrees is equal to 127 degrees. The other solution is done by using resolving of forces. Because particle is in static equilibrium, resultant force acts on the object at any direction is equal to 0. So forces is resolved vertically and horizontally. First, resolve forces vertically. You will get 5 sine theta equals to 4. That is equation number 1. Then resolve forces horizontally. You will get 5 cosine theta equals to 3. That is equation number 2. Divide equation number 1 with equation number 2. You will get tangent theta equals to 4 over 3. And theta is equals to 53 degrees. So, alpha is equals to 180 degrees minus 53 degrees is equals to 127 degrees. Even though there are two methods to solve problems of static equilibrium of a particle, if there are many forces act on the particle and triangle of forces cannot be drawn, then resolution of forces should be used. Let's look at a rigid body in static equilibrium. A rigid body is an object that is hard to change shape. If a rigid body is exerted by two equal forces in magnitude and opposite in direction, the rigid body will experience two motions, which are rotational motion and translational motion. A pair of equal in magnitude and opposite in direction forces cause a rigid body to rotate is called couple. Direction of translational motion can be found by using right-hand cross product rule. Direction of rotational motion can be determined by considering the forces act on the rigid body. There are two directions of rotational motion, clockwise and counterclockwise rotational motion. In STPM, if counterclockwise rotation is considered as positive torque, then clockwise rotation is considered as negative and vice versa. For a rigid body which is pivoted at a point, the rigid body will not move in the direction of translational motion, but it can still be rotated. The moment of force that causes the translational and rotational motion is known as torque. Torque is defined as the cross product of vector product of R and F. In order to find the magnitude of torque, you must make sure that you have resolved the distance R so that it is perpendicular to the force F. So, for the first case, torque is equal to R multiplied by F. And for the second case, torque is equal to R sin theta multiplied by F. Look at the example of determining the value of torque shown in diagram below. If counterclockwise rotation is considered as positive torque, then the resultant torque is 164 Newton meter. So, for a rigid body to be in static equilibrium, two conditions needed. Resultant force at any direction is equal to 0, and resultant torque at any axis of rotation is equal to 0. What will happen to the diagram of forces of a rigid body in static equilibrium? These are some examples of static equilibrium of a rigid body. We can conclude that a rigid body is said to be in static equilibrium if all the forces act on a common point. In order to solve problem of static equilibrium of a rigid body, the following steps should be followed. Step 1. Label all the forces act on the rigid body. Step 2 and Step 3 depends on which one you want to apply first. That is, either you apply the condition of resultant force at any direction is equals to 0, or resultant torque at any axis of rotation is equal to 0. Look at the example about equilibrium of a rigid body. Calculate the tension T in the back muscle and the compression H on the backbone. The tension T in the backbone and the compression H on the backbone can be found by taking moment about the pivot 60L plus 250 multiplied by L over 2 equals to T multiplied by 2 over 3 L sine 12 degrees. You will get tension T equals to 1335 Newton. Resolving force horizontally, you will get tension T cosine 12 degrees equals to H. So H is equal to 1306 Newton. I hope my explanation on topic statics can help you to understand this topic and master the learning objective. To test your understanding about this topic, let us look at the following questions. First question: which of the following is correct for a particle in static equilibrium? The answer is C. Second question: which of the following is correct for a rigid body in static equilibrium? The answer is D. As an enrichment practice, look at the following questions and students can discuss your answer with your friends or your teachers. Question 1. Question 2. That's all for this episode. I hope you can achieve the learning objective for today. Till we meet again in the next episode. Bye.